Hello, ladies and gentlemen. So today we're talking about different properties of logs. So how do we do things when we have logs with plus signs and multiplication and simplifying? So we're going to be talking about how we work with these logs a little bit more. Remember, we're working to solving, so some of these properties are going to help us later. You do need another foldable for expanding and condensing, where we're going to write those properties and do a few examples. So this is what the outside of that property foldable looks like. And these are properties of logs, and they also work with natural logs as well, because natural logs are just a special type of log. So we have both natural logs and typical regular logs, okay? And all of these follow the same properties. So we're talking about product property, quotient property, and the power property today. What do we do when we have powers or exponents? What do we do when we see multiplication? What do we do when we see division? So let's start with the product property. When you have a log of two things being multiplied, you can break it apart into two logs being added. So the log of the quantity A times B turns into the log of A plus the log of B. So the log of the first thing plus the log of the second thing. Now when we have the quotient property, so that's division, we do the opposite. So when we have the log of something divided by something else, like A divided by B, we take the log of A, or the numerator, minus the log of the denominator to expand or simplify that expression. And then the power property looks kind of funny, but this is what it looks like. When you have the log of something to a power, like A to a power, basically that exponent flies in front of that log right here, and it becomes B, the exponent, times the log of A. So these properties are either expanded or condensed. This side over here is considered the condensed side. This side over here is the expanded side. Notice how it got a little longer in how we wrote it. We had more plus signs and minus signs when things are expanded. So why are we doing all of this? Where do these properties come from? Well, let's remember that a log is like saying what exponent. So we're talking about equaling exponents here. When we talk about a log equation, it equals the exponent on that other side, right? 2 to the exponent equals x. So a log equals the exponent. So when we work with logs, let's use our exponent rules. When do we add exponents? When things were being multiplied, right? That's when we added the exponents. So when did we add the logs? When things were being multiplied. When we subtract exponents, when things were being divided. So we would subtract the exponents right here. And when do we multiply exponents? When we had powers onto powers. So it follows that all of these properties come from that. When we have multiplication, we added the exponents. We're going to add the logs. When we have division, we subtracted the exponents. So we're going to subtract the logs. Those properties tie into our log properties because logs are the inverse of the exponents, okay? So this is what we're talking about then, using these properties to expand and condense expressions. So we need to open up these little flaps, and you're going to see some examples that you need to write in there. And then there's a few multiple step examples that you also need to write in your notes someplace, or maybe on the back, wherever you want to, okay? So inside the first flap, this is product property examples. So this is us using that product property. So when we expand a log expression, we have the log base 3 of the quantity 5 times x. So notice we have multiplication going on in here. When we expand it out, we do so by turning it into addition. So we'd say I have the log base 3 of 5 plus the log base 3 of x. So the log base 3 of the first thing and the log base 3 of the second thing, expanded out with a plus sign, okay? This would allow me to evaluate one part of it even if I couldn't evaluate the other. This would be helpful when we're solving. Now, what if I have three things in here? This is a log base 10 of 6 times x times y. So I'd have log base 10 of the first thing plus log base 10 of the second thing plus log base 10 of the third thing. So we expanded it all out. Notice it started on a condensed side and then it expanded all out to have multiple terms. So what if we had to work backwards? What if I have the log base 3 being expanded out to both 2, 11, and 7? Log base 3 of 2 plus log base 3 of 7, or 11 plus log base 3 of 7. What did this look like when it was all condensed? Well, remember we're dealing with a log base 3, and what does the addition signs represent to us or tell us? It tells us that some things were being multiplied inside some parentheses or in the quantity. What was being multiplied? Well, the 2, the 11, and the 7 were all being multiplied as a quantity inside there. That's how somebody expanded it out to log base 3 of 2 plus log base 3 of 11 plus log base 3 of 7. So now if I wanted to condense even further, I'd say I have the log base 3 of what is 2 times 11 times 7. If I need to simplify that further, and most of the time I will, I would go ahead and calculate that and get 154. So I could then evaluate from there if I needed to. But that is as condensed as we need to get it there. It's all simplified down into one log expression. So let's now look at the quotient property. Now with quotients or division, we're not going to add, we're going to actually subtract. So in this first one, we want to expand. This one has a log, no base. So remember, what does that mean? Base 10, right? So we have the log base 10 of 6 divided by x. So with division, when we expand it out, we'd have the log base 10 of the first thing again, minus the log base 10 of the second thing, or the numerator minus the denominator. All right, we've expanded that expression out into two parts or two terms. Now, if I have to condense backwards, we just need to do this in reverse. Notice how I have a natural log on both of my terms. That means I was dealing with a natural log. What was happening with that natural log? Were things being multiplied? Were things being divided? Well, notice the subtraction sign tells me that something was being divided. That's the quotient property for logs, that subtraction is equivalent or the same there as division when we expand it out or condense it back. So I would have 2 divided by 8. So 2 divided by 8 would have been my expression. Notice natural log 2 over 8. Now I could simplify that some more, right? Natural log of 1/4. So this is my condensed version of all of this. So in times when I need to solve and I need to condense to help me, this would be a skill that we'd need. Now let's condense this next one and we should be good to go on the quotient property. So this one is a log base 4 of both parts. So we're going to write log base 4. What was happening? Well, we had a 3 divided by an 8. So 3 divided by an 8. Can we simplify 3/8? Nope. So we would just leave it as is. This is the condensed log expression, okay? So last but not least, let's do that power property. And then we're going to get into some multi-step ones here in a minute. So let's expand this one out. We have a log base 4 of a times b, but they're both being taken to the second power. Okay, both of them have that exponent of a 2. So I might write it as a squared and b squared in those parentheses rather than just writing it like that. So I have log base 4 of a squared times b squared. Now, when you have a multiplication sign, remember, check this out. What did we do? Well, we turned it into a log expanded problem by using a plus sign. So we do log base 4 of a squared, that's the first thing, plus log base 4 of b squared, that's the second thing. And now the deal with the exponents, now here's the power product, or power property, sorry, is that you multiply it in front like this, and that 2 goes in front, okay? And the same deal with this guy, that 2 is going to go in front. So when he's all expanded, he's going to become 2 log base 4 of a plus 2 log base 4 of b. So when he's all expanded out, the powers go in front of the corresponding log. So let's look at the second one here. Now there's a weird square root in this one, right? Look at that. It's just over the 7 though. So if I were to rewrite this, isn't the square root of 7 the same thing as 7 to the 1/2 power? Yep. So now that square root doesn't look so scary, and now he's just an exponent that I can write in front of the log. So again, this has a product in it. So I'd write log base 5 of 7 to the 1/2 plus log base 5 of the x. Now the exponent on this 7 flies in front of his log, so we end up with 1/2 log base 5 of 7 plus log base 5 of x. Okay, so we can end up expanding things out if we need to during the solving process, and those powers just become coefficients in front of the log. Let's condense one backwards here to practice that part. Notice we have a 1/3 in front of the word log. That means he was an exponent on this 6. So what we had was log of a 6. There's no base on this, so remember that's base 10, okay? Log base 10 of 6 to the 1/3. Now, 6 to the 1/3 can also be written as log base 10 of 6 in a cube root sign, right? This is his condensed version of that expression on the left, all expanded out, okay? So we're using these product and our power properties and quotients and product properties when we expand things out and also when we condense back. So here's two multi-step properties here, or two examples, and then we should be good on our notes today. So let's expand out this expression right here. So notice this is saying that everybody in here has a 5 power, the 6, the x, and the 11. So if you want to first, you can think about that being given to everybody, or we can expand it out first and then basically give the power to everybody's log as well. So log, if I'm going to first deal with that 5 power, I'd have 6 to the 5th, x to the 5th, and 11 to the 5th. And now up on top of the fraction, let's start there. We would have log of 6 to the 5th plus, because we have a time sign, log x to the 5th. Now we're going to divide, divided by, which means subtract, log 11 to the 5th. Now the only thing that's not too great here is we still have those exponents on there. So remember what they do, they fly in front of the log that corresponds with them. So we'd have 5 log of a 6 plus 5 log of an x minus 5 log of an 11. Okay, so see what I mean by you could have waited till the end to put all those 5s in front if you wanted to. However you get there, this is your final answer, all expanded out. And now let's condense one back. I have 4 times the log base 3 of x minus 20 times the log base 3 of y. So let's figure out what these numbers in front of the logs mean. Remember, they were exponents. So this used to be x to the 4th, and this used to be y to the 20th. So I had an x to the 4th and a y to the 20th. That's how these coefficients went in front of the logs. Now what? Well, now we have a subtract sign in between these logs, which meant there was division. So we now have log base 3 of something being divided. What was being divided? Well, the x to the 4th comes first, that's the numerator, and the denominator has to be that y to the 20th. Is there anything more we can do to condense this? Nope. Notice how the word log base 3 is only written one time. It's not log on top and log on bottom. That's a big deal. Okay, make sure you only have the word log written one time, otherwise it's not completely condensed. All right, I want to thank you, ladies and gentlemen, for taking good notes. We're going to use these properties and practice, practice, practice so that we can solve well, okay? I want to thank you for taking good notes again, and Kincaid out.